Welcome back to Statistics Made Simple, and I am Savita Valsam. In this video, I am solving the second PUC practice question paper 1 for the year 2023-2024, which follows the new pattern. The second PUC final examination question paper for the year 2023-2024 will be for 80 marks, and the duration for the paper is 3 hours 15 minutes. There are certain instructions to be followed while answering the paper. The statistical table and graph sheets will be supplied on request. Scientific calculators are allowed. All working steps should be clearly shown, and only the first written answers will be considered in Section A. Section A. Choose the correct answer from the choices given. 5 into 1 is equal to 5. First question, the capacity of a woman to bear children is called mortality, fertility, fecundity, and growth. The correct answer is fecundity. Second one, the condition for the time reversal test to be satisfied with usual notation is first option, P01 into P10 is 1, P01 into P10 is equal to 0, P01 into Q01 is equal to V01, and fourth option is P01 into Q01 is equal to 1. The correct answer is P01 into P10 is equal to 1. Third question, in a binomial distribution, if NP is equal to 3, then the relation between mean and mode is first subdivision, mean is equal to mode, second mean is not equal to mode, third mean is greater than mode, and mean is less than mode. We have learnt a property in the binomial distribution that whenever NP is an integer, that means it has only the integer part and not the decimal part, then in such a situation the mean is equal to the mode. Fourth, in the following four statements, size of the test is equal to probability of type 1 error, size of the test is 1 minus probability of type 1 error, power of a test is equal to probability of type 2 error. Fourth is power of a test is equal to 1 minus probability of type 2 error. The correct statements are 1 and 3, 1 and 4, 2 and 3, and 2 and 4. So the correct answers are 1 and 4. So the option is B. Fifth question. A game is said to be fair if subdivision A, value of the game is 3, value of the game is 2, value of the game is 1, and value of the game is 0. The game is said to be fair when the value of the game is 0. So the correct option is D. Second main, fill in the blanks by choosing the appropriate answer from those given in the brackets. The choices are 10, setup, 5, chance, static, and average. 5 into 1 is equal to 5. Sixth one, index numbers are specialized type of. The answer is averages. Seventh one, in a chi-square distribution, if variance is equal to 10, the mean is. So let me show you the calculations here at the side. We know that variance of chi-square is equal to 2n, and in the question they mentioned that it is equal to 10. So which implies n is equal to 10 divided by 2, which is 5. And we are aware that the mean of the chi-square distribution is E of chi-square is equal to n. So the correct answer is 5. A function of sample values is called a statistic. And ninth one, a small amount of variation for which no specific cause can be attributed is termed as chance cause of variation. Then inventory reduces the setup cost. So that's the 10th question. The third main, match the following. In the A column, you have size of the cohort, retail price of commodities, mean of a T distribution, H1 mu is less than 10 and matrix minima method. The size of the cohort is called as the radix. Retail prices of commodities, that is associated with the cost of living index number. Then mean of a t distribution, that we know that it is always 0. Then H1 mu is less than 10. That is the alternative hypothesis. So H naught mu equal to 10 will be the null hypothesis. Matrix minima method, the method used for a transportation problem's solution. Fourth main, answer the following questions. 5 into 1 is equal to 5. The 16th question, write the formula for estimating the population between census years. So the formula is PT is equal to P naught plus B minus D plus I minus E, where PT is the population at time t, P naught is the population in the census year, B and D are the number of births and deaths respectively, and I and E are the number of immigrants and emigrants. 17th question, name the graph used in representing the time series data. So the answer is the histogram. 18th question, write the range of a t distribution. So the range is written as minus infinity is less than t is less than infinity. It is read as t can take any value between minus infinity and infinity. Define alternative hypothesis. So a hypothesis which is accepted when the null hypothesis is rejected is called the alternative hypothesis, and is denoted by H1. 20th question, what is meant by maximum in a game theory? So maximum is defined as the maximum of the row minimums. Okay, so it is the maximum of the row minimums in a payoff matrix. Section B. Fifth main, answer any 5 of the following questions. These are 2 markers. 5 into 2 is equal to 10. 21st question, mention a cause of the following variations in a time series: seasonal variation and irregular variation. So let's start with seasonal variation. There are 2 causes for seasonal variation. One is from those resulting from man-made conventions, and second is those resulting from natural forces or weather conditions or climatic conditions. For irregular variations, the changes that take place as a result of forces which cannot be predicted, like floods, famines, tsunamis, earthquakes, epidemics, strikes, fires, lockouts, etc., are the irregular variations. 22nd question, Write the conditions for the application of binomial expansion method of interpolation and extrapolation. The two conditions are the x value should be equally spaced, and secondly, the value of y which has to be estimated should be corresponding to the value of x in the given data. 23rd question, if Q is equal to 0.4, then find the variance of a Bernoulli distribution. So let's write down what is given. So Q is equal to 0.4 implies that P is equal to 1 minus Q, which is equal to 1 minus 0.4, that is equal to 0.6. So now let's write the formula for the variance of the Bernoulli distribution. So consider V of x is equal to PQ, which is 0.4 into 0.6. So the answer is 0.24. 24th question, in a Poisson distribution, if mean is 9, find the standard deviation. So the mean of the Poisson distribution means it is E of x. We know that E of x is equal to lambda for the Poisson distribution, and in the problem this is equal to 9. So now let us write down the formula for the standard deviation of the Poisson distribution. So consider SD of x is equal to root of lambda, which is root of 9, which is equal to 3. 25th question, given n1 equal to 80, n2 equal to 40, p1 equal to 0.8 and p2 equal to 0.4, find the standard error of the difference of the sample proportions. So note that capital P1 and capital P2 are the population proportions. So let us find out Q1. Q1 will be 1 minus P1. 1 minus 0.8 is equal to 0.2. Similarly, find out Q2. Q2 is 1 minus P2, which is 1 minus 0.4, that is equal to 0.6. So let's write the formula for the standard error. So standard error of P1 minus P2 is equal to root of P1 Q1 by N1 plus P2 Q2 divided by N2. So substituting the values, we get root 0.8 into 0.2 divided by 80 plus 0.4 into 0.6 divided by 40. So simplifying further, this is equal to root of, it is 0.002 plus 0.006, and simplifying further, we get root of 0.008, which is equal to 0.089, which is the standard error of the difference of the sample proportions. 26th question, define estimator and estimate. An estimator is a statistic which is used for the purpose of estimating an unknown parameter. And an estimate is a specific value of the estimator for a specified sample. 27th question, if x bar dash is equal to 15 and sigma dash is equal to 2, for a sample size of 4, calculate the upper control limit for the x bar chart. This is case 1 when the process standards are given, that is x bar dash and sigma dash are given for the x bar chart. So let's write first given. Sample size of 4 means n is equal to 4. Then you have x bar dash is equal to 15 and sigma dash is equal to 2. Now let's write the formula for the UCL for the x bar chart. So consider UCL is equal to x bar dash plus A sigma dash. Okay. So within brackets from the tables for n equal to 4, the value of A is 1.5. So therefore, UCL is equal to 15 plus 1.5 into 2, which is equal to 15 plus 3. So the answer is 18. 28th question. The depreciation cost and cumulative maintenance cost of a machine during 4th year is rupees 4,000 and rupees 7,200 respectively. Compute the annual average cost. So let's write down the information which is given. Depreciation cost is P minus SN, which is equal to 4,000, and cumulative maintenance cost is summation CI, which is equal to 7,200. So P is the capital cost, SN is the resale value or the scrap value. And the question now is to find out the annual average cost during the 4th year. So which means that N is equal to 4. So let's write the formula for the average annual cost. Consider AN is equal to, it is P minus SN plus summation CI divided by N, which is equal to 4,000 plus 7,200 divided by 4, which is 11,200 divided by 4. So therefore A subscript 4, that is the annual average cost for the 4th year, is equal to rupees 2,800. Section C, 4th main, answer any 4 of the following questions. 4 into 5 equal to 20. These are the 5 markers. 29th question, calculate the simple geometric mean index number for the following data. In the first column, you have the items A, B, C, D. Then you have price in rupees for 2021 as 20, 25, 30 and 10. And for 2023, the prices are 25, 30, 25 and 8. So first let us mark the prices in 2021. So 2021 is the base year. So the prices will be marked as P0, and 2023 is the current year. So the prices in the current year are denoted by P1. Now let us first write the formula for the simple geometric mean index number. The simple geometric mean index number is also called as the unweighted geometric mean index number. So the formula is, consider P01 of GM is equal to, the formula is anti-log summation log P divided by N, where capital P is the price relative and has the formula P1 by P0 into 100. So P01 of GM carries 1 mark, the formula, and the price relative formula also carries 1 mark. So let us compute in the table capital P, which is P1 by P0 into 100. So it's 25 divided by 20 into 100. So we get 125. Next is 120. Then we get 83.33. And then similarly, 8 divided by 10 into 100 will give us 80. Now in the next column, we have to find out log of the price relatives, that is log of 125, that is 2.0969. Next, similarly, we find out log of 120, which is 2.0792. Then next is 1.9208, 1.9031, and we get summation log P, this total as 8. So computing here, so therefore P01 of GM is equal to, it is anti-log of 8 divided by the number of items which are given is 4. So that means n is 4, which is equal to anti-log of 2. So therefore P01 of GM is equal to 100. Thirtieth question, interpolate the value of y when x is equal to 34 from the following data by using Newton's forward difference method. So the first two columns are given. The x values are 30, 40, 50 and 60. The y values are 73, 198, 573, 1198. Now the first step is to mark 30 as x0 and 73 as y0. Then we need to form the leading differences column. So first we have delta to the power 1, then delta to the power 2 and delta cube. Now how do we find out delta to the power 1? That is the first leading difference is 198 minus 73. We get 125 and we write it in between these two values. Similarly, 573 minus 198 is 375. And 1198 minus 573 is equal to 625. In a similar way, find out the second leading differences, that is delta square. 375 minus 125 is equal to 250. 625 minus 375 is equal to 250. Then we find out the third leading differences, that is d cubed, that is 250 minus 250, it gives 0. So we stop here since only one value remains. Then 125, you should mark it as delta naught to the power 1, 250 as delta naught square and 0 as delta naught cube. Now let us first write the formula for Newton's forward difference method. So the formula is, consider yx is equal to y naught plus x delta naught to the power 1 plus x into x minus 1 by 2 factorial delta naught square plus x into x minus 1 into x minus 2 divided by 3 factorial delta naught cubed, where x is equal to, so how do we find out x? So x is the value for which y has to be interpolated. So it is 34 minus x naught. X naught from the table is 30 divided by the difference between the two x values, that is 40 minus 30. So this is given in the table or in the question, and this 30 is nothing but your x naught and 40 minus 30 is the difference between the x values. So we get 4 divided by 10 is equal to 0.4. So it's important to get the value of x right. So continuing, let me continue here at the top. So therefore y, for in place of this x you write 34 is equal to y naught is 73 plus 0.4 into 125 plus 0.4 into 0.4 minus 1 divided by 2 factorial is nothing but 2. Delta naught square is 250. Now the last term will be 0 because delta naught cubed is 0 and 0 multiplied by any term would be 0. So simplifying further, we get 73 plus 50 plus 0.4 into minus 0.6 into 250 divided by 2. so which is equal to 123. If I simplify this, plus into minus is minus, I will get 30. So the final answer is therefore Y34 is equal to 93. 31st question. 4 unbiased coins are tossed 80 times. Find the theoretical frequencies for the number of heads obtained. So let's start the problem. So first write given. 4 unbiased coins means n is equal to 4. It is tossed 80 times means capital N is equal to 80. And we have to find out the theoretical frequencies for the number of heads obtained. So probability of getting a head when a coin is tossed is 0.5. This is because of the word unbiased. Similarly, now find out Q, which is 1 minus P, that is 1 minus 0.5 is equal to 0.5. The next step is to define capital X as number of heads. So we are aware that a problem related to coins which is tossed more than once but a finite number of times follows the binomial distribution. So now let us write the PMF of the binomial distribution. We know that the formula is P of X equal to, open the flower bracket, it is NCX, so 4CX, P to the power X, 0.5 to the power X, Q to the power n minus x, so 0.5 to the power 4 minus x, and x takes values 0, 1, 2, 3 up to n. Here n is 4, and in the next line we write 0 otherwise. Now the next step is to find out the probabilities when x is equal to 0, 1, 2, 3 and 4. So when x is equal to 0, P of 0 is equal to 4C0, 0.5 to the power 0, 0.5 to the power 4 minus 0. So which is 1 into 1 into 0.5 to the power 4, which is equal to 0.0625. Similarly, when x is equal to 1, P of 1 is equal to 4C1, 0.5 to the power 1, 0.5 to the power 4 minus 1. So 4C1 is 4 into 0.5 into 0.5 to the power 3. So which is equal to, you will get 0.25 on simplification. Similarly, when x is equal to 2, P of 2 is equal to 4C2, 0.5 to the power 2, 0.5 to the power 4 minus 2, which is equal to 4C2 is 6 into 0.25, and again you will get 0.25, and on simplification we get 0.375. Similarly, when x is equal to 3, P of 3 is equal to 4C3, 0.5 to the power 3, 0.5 to the power 4 minus 3. So 4C3 is 4 into 0.125, and then here you get 0.5 to the power 1 is 0.5, and on computation you get 0.25. And lastly, when x is equal to 4, P of 4 is equal to 4C4, 0.5 to the power 4, 0.5 to the power 4 minus 4. 4C4 is 1. Then you get 0.0625 into 0.5 to the power 0 will be 1. And so you get 0.0625. So note that whenever P is equal to 0.5, the binomial distribution is symmetric, so the probabilities in the beginning and at the end will be the same. Now we form a table. In the first column, we'll write number of heads, which is nothing but x. In the second column, we have P of X, that is the probabilities which we found out. And then we calculate Tx, which is capital N into P of X. So Tx is called as a theoretical frequency or the expected frequencies. Now we know that in the problem, we have X as 0, 1, 2, 3 and 4. So N is equal to 4. Then the probabilities which we found out were 0.0625, then 0.25, 0.375, then again we had 0.25 and 0.0625. Next column 0.0625 should be multiplied with capital N, which is 80. So you get 50. The next one is 20. How did we get 20? It is 0.25 into 80 is 20. The next value is 30, then 20, and then we have 5. When you add up all these theoretical frequencies, we have to get capital N, which is 80. So now suppose any of these theoretical frequencies are in decimals, then we have to round them off to the closest whole number. 32nd question. A basket has 10 mangoes, out of which 6 are ripe. 3 mangoes are randomly selected. Use hypergeometric distribution and find the first subdivision, the expected number of ripe mangoes among the picked ones, and the second subdivision, the probability that all the picked mangoes are ripe. So it's already stated that the problem is based on the hypergeometric distribution. So let's start the problem. The question is asked with respect to ripe mangoes. So A will be the number of mangoes which are ripe and B will be the number of mangoes which are unripe. So let's write the data which is given. So given A plus B is equal to 10. A stands for the number of ripe mangoes, which is 6, and B is equal to 10 minus A, which is 10 minus 6 is equal to 4. And then they've used the word randomly selected, which means that N is equal to 3. So now that we have written the given part, the next step is we have to write down what is the random variable X. So let me define capital X as number of ripe mangoes in a random sample of size n equal to 3. Now I'll write down the PMF of the hypergeometric distribution. P of X equal to, it is ACX, so 6CX, BCN minus X, so 4C 3 minus X, divided by, it is A plus B Cn, that is 10C3, and X takes values 0, 1, 2, so on. It is minimum of A comma N, so 6 comma 3. So this is A and this is N, and the minimum of these two values is 3. Okay, so we get P of X is equal to 6CX 4C3 minus X divided by 10C3 is 120, and X takes values 0, 1, 2 and 3. Now starting with the first subdivision, they've asked us to find out the expected number of ripe mangoes among the picked ones. So it means that we have to find out expectation of X. The formula is NA divided by A plus B. So it is 3 into 6 divided by 10. That is 18 divided by 10 is 1.8. Now similarly, the next subdivision, we have to find the probability that all the picked mangoes are ripe. So how many mangoes did we pick? We picked 3 mangoes and all of them should be ripe, means we have to find out probability of capital X equal to 3, which is equal to P of 3. Now in the PMF, wherever you have X, replace it by 3. So 6C3, 4C3 3 minus 3 divided by 120. So 6C3 is 20, and here you will get 4C0 divided by 120. So 4C0 is 1. So the answer is 20 by 120, or 0.1667. So remember that probability should always lie between 0 and 1. 33rd question. In a sample of 400 people in Kerala, 180 are coffee drinkers and the rest are tea drinkers. Can we assume that both coffee and tea are equally popular in the state? Use 1% level of significance. So let's start the problem. First, check the words which are used in the problem. As the problem does not have the words like mean, average, variance, standard deviation, and it is based on only one sample, so it is test for single proportion. So when we have a test for single proportion problem, we need to get 3 values from the question. So let's write down the values which are given. So starting, they've said in a sample of 400 people, that means n is equal to 400. 180 are coffee drinkers. So X stands for number of units which possess a characteristic or an attribute in the sample. So X is equal to 180. So now the only value which we have to get is capital P naught. Now they have mentioned that tea and coffee are equally popular. So when they say that tea and coffee are equally popular, what it means is that P naught is equal to 0.5. That is, the proportion of coffee drinkers is 0.5, and Q naught, which is 1 minus P naught, will be the proportion of tea drinkers. That also will be 0.5. So how do you find out Q naught? It is 1 minus P naught, which is 1 minus 0.5 is equal to 0.5. And they have said that we have to use alpha as 1%. The next step is to define the null hypothesis and the alternative hypothesis. So H naught is, in general, the statement is the population proportion is P naught. Here P naught is 0.5. So that is capital P is equal to 0.5 versus the alternative will be two-tailed. That is H1 P is not equal to 0.5. Next, under H naught, the test statistic is, the formula is Z equal to P minus P naught divided by root P naught Q naught by N, which follows normal 0, 1. And small p is called as the sample proportion, which has the formula X by N, which is 180 divided by 400. Which is equal to 0.55. So substituting, we get Z is equal to 0.55 minus 0.5 divided by root of 0.5 into 0.5 divided by 400. So it simplifies to 0.05 divided by root 0.25 divided by 400, which is 0.05 divided by 0.025, and we get the value as 2. So now let me write the condition which will help us to accept or reject H naught when the alternative is two-tailed. So to check whether mod Z is greater than or equal to K alpha by 2. So if this condition is satisfied, you reject H naught, otherwise you accept H naught. So we had found out mod Z. So therefore, mod Z is equal to modulus of 2, which is equal to 2. Okay, so next at 1% level of significance, we need to find out K alpha by 2. So from the tables, it is 2.58. So now let us write the conclusion. So you have to compare mod Z with K alpha by 2. So since mod Z is equal to 2, it is not greater than K alpha by 2, which is equal to 2.58. So at 1% level of significance, if it was greater, then you would have rejected H naught, but 2 is not greater than 2.58. So at 1% level of significance, we accept H naught and conclude that whatever is there in H naught statement, you have to write that, that is capital P is equal to 0.5. 34th question, IQ of 5 students is given before and after training. Is the training effective? Use 5% level of significance. Now, usually when a question has before and after, it comes under the paired t-test. That is t-test for equality of means for dependent samples. So in the first column, they have given us the students 1, 2, 3, 4, 5. Then their IQ before training as 120, 125, 118, 136, 121. And their IQ after training, this is for the same set of students, is 130, 123, 120, 132, 125. Now the first step is to mark IQ before training as X and IQ after training as Y. Let's start the problem. We will write given n is equal to 5. Then they have also given us alpha. So alpha is 5%. So for the paired t-test, let us write H naught. I'll write H naught here. So H naught, the two population means are equal. That is mu1 is equal to mu2 versus H1. We have to write H1 based on the problem. So let me give the explanation here within brackets. So before training, the mean IQ, I'll denote it as mu1, and after training, the mean IQ is denoted by mu2. So the question they are asking is whether the training is effective. So whether the training is effective means they are asking whether mu2 is greater than mu1. In other words, we have to check whether mu1 is less than mu2. So our H1 will be mu1 is less than mu2. Next, under H0, the test statistic is T equal to, it is D bar divided by S by root n minus 1, which follows Tn minus 1. So to calculate this D bar, first we need to calculate D. So D is nothing but the difference between the X and Y values. So 120 minus 130 minus 10. Next is 2. Then you have minus 2, 4 and minus 4. Next you have to calculate summation D, which is required for D bar calculation. So summation D is minus 10. We will also need D minus D bar the whole square, which in this case will be D plus 2 the whole square. This I will require for the calculation of S. So I am doing the calculation in this slide itself. So now how do you find out d plus 2 the whole square? It is minus 10 plus 2 is minus 8. Minus 8 square is 64. Similarly, 2 plus 2 is 4. 4 square is 16. In a similar way, find out d plus 2 whole square for the remaining values. So you will get 36 and then you will get 4. So summation d plus 2 the whole square is equal to 120. So let me now write the formula for d bar. So d bar is equal to summation d divided by n. Summation d we had got as minus 10 divided by 5 is equal to minus 2. Then similarly, we have to write the formula for S square. S square is summation d minus d bar the whole square by n, which is equal to summation d minus d bar is minus 2 the whole square and n is 5. So we get S square is equal to summation d minus into minus is plus 2 the whole square divided by 5. So from the table we got summation d plus 2 the whole square as 120 divided by 5, which is equal to 24. Now let us substitute all these values in d. So therefore we get d is equal to minus 2 divided by, in the denominator we need s, but here we have calculated s square, so which implies s is equal to root of 24, and root of 24 is 4.8989 if I take 4 places after the decimal after rounding off. So in the denominator here you substitute 4.8989 divided by root of n minus 1 is 5 minus 1. So which is equal to minus 2 divided by 4.8989 divided by root of 4 will be 2. So on simplification we will get minus 0.8165. Now at this side I will write the condition for the t-test when the alternative is left tail. So the condition is you have to check whether mod t is less than or equal to minus t alpha. So if this condition is satisfied, you reject H naught, otherwise you have to accept H naught. So now let us find out what is the degrees of freedom. So degrees of freedom is n minus 1, which is 5 minus 1 is equal to 4. We have the value of t. Now we need to find out what is minus t alpha. Okay, so at 5% level of significance for 4 degrees of freedom, minus t alpha is equal to minus 2.13. So this you can obtain from the tables. Now the last step is to write the conclusion. So since t is equal to minus 0.8165 and minus t alpha is equal to minus 2.13, you have to check whether minus 0.8165 is less than minus 2.13. So it is not less at 5% level of significance for 4 degrees of freedom. You will accept H naught and conclude that mu1 is equal to mu2. 35th question. Determine an initial basic feasible solution to the following transportation problem by northwest corner rule. compute the transportation cost. So 3 origins O1, O2, O3 are given and 3 destinations D1, D2, D3 are given along with the availabilities, that is A1, A2, A3, and the requirements at the destinations as B1, B2 and B3. So note that summation AI should be equal to summation BJ, which is equal to 36. That means it is a balanced transportation problem. So as you're all aware, this particular cell, which has the cost as 2, is cell 1, 1. This is 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. So in the northwest corner rule, the first allocation is made in the cell 1, 1. So x11 is equal to minimum of a1, b1, which is equal to minimum of, it is 9, 10, which is equal to 9. Now 9 should be written in this cell here. Now compare 9 with the availability or with the requirement. We see that this 9 matches with the availability at O1. So we write availability at O1 is satisfied. So whenever availability is satisfied, you have to move vertically down and then make the allocation x is equal to, so whenever availability is satisfied, the formula for the allocation is x is equal to minimum of, it is a comma b minus x. So we have come to this cell is 2, 1, so the subscript will be x21 is equal to minimum of a2 comma b1 minus the allocation which we just now found, that is x11. So which is equal to minimum of a2 is 14 comma 10 minus 9, which is minimum of 14 comma 1. So the minimum is 1. So next write 1 in this cell here. Now check whether 1 matches with the availability 14 or it matches with the requirement 10. It doesn't match with both, but in this particular column, when we add 1 plus 9, you get 10. So what we see is that the requirement at D1 is satisfied. So now we write requirement at D1 is satisfied. So now when a requirement is satisfied, you have to move to the right cell. So we were here, so now we have to move to the right, means draw an arrow from this cell to this particular cell over here. Now this cell is x22. So when requirement is satisfied, the formula for the allocation is x is equal to minimum of, it is a minus x comma b. So it is x22 is equal to minimum of, this 2 you write for a and this 2 you write it as a subscript for b, and this x will be the allocation which you just now found out, which is x21. So we get x22 is equal to minimum of, it is 14 minus 1 comma b2 is 15. So this is minimum of 13 comma 15, and so the minimum is 13. Next write 13 in this cell. Now 13 doesn't match with 14, 13 doesn't match with 15. But in this particular row, there is another allocation. So when we add 13 and 14, it matches with 14, that is the availability at O2. So we write availability at O2 is satisfied. Okay, so now when availability is satisfied, you have to move vertically down. So we move down and use the formula for the allocation as x is equal to minimum of A, comma, B minus x. So this particular cell is 32. So x32 is minimum of this 3 you write for A and 2 you write as a subscript for B. And this x will be the allocation which you found out, that is x22. So which is equal to minimum of 13, comma 15 minus 13, which is equal to which is equal to minimum of 13 comma 2, which is equal to 2. Next write 2 here. So 2 doesn't match with 13 nor does it match with 15, but this particular column, when we add 13 and 2 you get 15, which matches with the requirement at D2. So we write requirement at D2 is satisfied. So when a requirement is satisfied, we have to move to the right. So move to this cell here, that is 3, 3, and make the allocation x is equal to minimum of A minus x comma B, and this is x33 is equal to minimum of A3, and this B will have a subscript as 3 and x subscript will be 3, 2. So this is equal to minimum of 13 minus 2, comma B3 is 11, which is nothing but minimum of 11, comma 11. So we get x33 is equal to 11. Now write 11 here. Now just check, 9 matches with 9, 1 plus 13 is 14, 2 plus 11 is equal to 13. So the availabilities at the origins are satisfied. Then 9 plus 1 is 10, 13 plus 2 is 15, and 11 is the requirement at D3. So the requirements at the destinations are also satisfied. Next we'll write, therefore, the total transportation cost is, so we write z is equal to 2 into 9 plus 1 into 1 plus 3 into 13 plus 5 into 2 plus 3 into 11. So each of the costs are multiplied by its allocation. So we get, therefore z is equal to rupees 101. 36th question. A particular item has a demand of 9,000 units per year. The cost of one procurement is rupees 100 and the holding cost per unit is rupees 2.40 per year. The replenishment is instantaneous and no shortages are allowed. Determine the number of orders per year and also find the annual average cost. So this is a problem on inventory theory, and as shortages are not allowed, it is model 1, that is without shortages. So let us write the data which is given. So given demand is denoted by R, which is equal to 9,000. Then the cost of one procurement, that is C3, is equal to rupees 100. And then the holding cost per unit, so that is C1, which is rupees 2.40 per year. And then they have said that shortages are not allowed. So it means that C2 is equal to 0. So let's not get confused and write that value. So let's start with the first subdivision, that is the number of orders per year. So number of orders per year, it is given by N naught, which is equal to R divided by Q naught. So where we have to first find out Q naught. q to the power 0 is equal to root 2r c3 divided by c1. So we get q to the power 0 is equal to root 2 into 9000 into 100 divided by 2.40. So which is equal to root of 7,50,000, or you get 866.025 units, or which implies q to the power 0 is equal to, I'll round it off to 866 units. So therefore n to the power 0 is equal to 9000 divided. So we get n to the power 0 is equal to 9000 divided by 866, which is 10.39 orders per year. Next, let us find out the annual average cost. The annual average cost is denoted by C into q to the power 0, which is equal to root 2rc3c1, which is equal to root 2 into 9000 into 100 into 2.40. So on simplification, we get rupees 2078.46. 7th main. Answer any two of the following questions. 37th question. The daily wages of workers of a factory are normally distributed with mean rupees 700 and standard deviation rupees 40. Find the probability of workers whose daily wages will be, first subdivision, between 690 and rupees 720. Second subdivision, more than rupees 800. So the given question is based on the normal distribution. So we know that the parameters of the normal distribution are mu and sigma. So let's start the problem. Write given. Mu is 700. Sigma is equal to 40. Next step, we will define X as daily wages of workers. That is, X follows normal 700, 40 square. Then write the standard normal variate formula. We know that Z is equal to X minus mu by sigma, which follows normal 0, 1. Now let's start with the first subdivision. Subdivision A. Consider probability of 690 is less than X is less than 720. So this is read as X lies between 690 and 720. The next step is to standardize. So this is equal to probability of 690 minus mu divided by sigma is less than X minus mu divided by sigma is less than 720 minus mu divided by sigma. So which is equal to probability of 690 minus 700 divided by 40 is less than Z is less than 720 minus 700 divided by 40. So simplifying further, this is equal to probability of After we simplify, we'll get minus 0.25 is less than z is less than 0.25. So now let us draw the normal curve. Center line you mark as z equal to 0. This is minus infinity and infinity. Now take the first value here. Minus 0.25 is negative. So mark it on the left tail. So z is equal to minus 0.25. Then 0.5 is positive. So mark it on the right tail. And as z lies between these two values, you have to shade only between minus 0.25 and 0.5. Now the area which you have shaded, you write it in words. So this is equal to area from minus 0.25 to 0.5. Now from the starting point of the shading till infinity, draw a bracket. And from the ending point of the shading till infinity, you draw a bracket. So this is equal to area from minus 0.25 to infinity minus the area from 0.5 to infinity. So therefore, probability of 690 less than x less than 720 is equal to 0.5989 minus 0.3085, and the answer for the first subdivision is 0.2902. So starting with the second subdivision, consider probability of x greater than 800, which is equal to probability of x minus mu divided by sigma is greater than 800 mu minus mu divided by sigma. That is, you have to standardize. So this is equal to probability of z greater than 800 minus 700 divided by 40, which is equal to probability of z greater than 2.5. Next, draw the standard normal curve. The center line is z equal to 0. The extremity is minus infinity and infinity. 2.5 is positive, so mark it on the right tail of the curve. And whenever you have the greater than symbol, you have to shade to the right of the value. So in other words, it means that z greater than 2.5 means from 2.5 till infinity you have to shade. Now the area which you have shaded, you write it in words, which is equal to area from 2.5 to infinity. Okay, so from the tables you can find out the area from 2.5 to infinity, which is 0.0062. So therefore, probability of x greater than 800 is equal to 0.0062. 38th question. 70 accidents that occurred in a state in a week are tabulated as follows. Test whether accidents occur uniformly throughout the week. K2 value is 16.81. So the given problem is based on chi-squared test for goodness of fit. They have given us days in the first column and number of accidents in the second. The number of accidents are 7, 8, 11, 12, 5, 13 and 14 for different days of the week. So let us mark day as X and number of accidents as O, and it is also the frequencies F. So when we add up we get capital N is equal to summation O is equal to 70. Now let's start the problem. First, we will write given capital N is equal to 70, and they've given us a value of K2 as 16.81. The next step is to write H naught. H naught will be whatever is asked in the question. It will test whether accidents occur uniformly throughout the week. So H naught is accidents occur uniformly throughout the week versus H1 accidents do not occur uniformly throughout the week. Next, we write the test statistic. So under H naught, the test statistic is chi-square equal to summation O minus E whole square divided by E, which follows chi-square n minus 1, where E is equal to capital N into P of X, and in this problem it is 70, and P of X, X stands for the days in a week. P is the probability of an accident occurring on any day in a week. So this is 70 into 1 by 7, which is equal to 10. So now in the table, form a column E and throughout write 10. Then we need to find out O minus E whole square divided by E, so which is nothing but 7 minus 10 is minus 3. Minus 3 square is 9. 9 divided by 10 is 0.9. In a similar way, 8 minus 10 is minus 2. Minus 2 square is 4. 4 divided by 10 is 0.4. Next is 0.1, 0.4, 2.5, 0.9, and 1.6. So summation O minus E whole square by E is equal to 6.8. So therefore, chi-square is equal to 6.8. Now the condition which we use for chi-square test for goodness of fit is it is a right tail test. So you have to check whether chi-square is greater than or equal to K2, and if this condition is satisfied, then you reject H naught. So this is the condition which you're using. So now let us write the conclusion. Conclusion: since chi-square is equal to 6.8 and K2 is equal to 16.81, you have to check whether 6.8 is greater than 16.81. It is not greater. So at alpha level of significance for 6 degrees of freedom, we accept H naught. And you conclude that accidents occur uniformly throughout the week. 39th question. 10 samples, each of size 50 items, were inspected, and the number of defectives in each of them were as follows. They've given us the sample numbers from 1 to 10, and the number of defectives are 1, 3, 4, 2, 3, 4, 1, 2, 3, 2. And they've asked us to calculate the control limits for the NP chart. Okay, so the NP chart is also known as the D chart, and the number of defectives, it is nothing but D. Okay, so you can mark the number of defectives as D, and when we add up the defectives, we get summation D is equal to 25. Now, the control limits for the NP chart have to be found out. Since the table is given to us, it is case 2 when the process standards are unknown. So let us start with the problem. So first write given. K stands for the number of samples, which is equal to 10. And in the question they have said each sample is of size 50, means N is equal to 50. Then side heading you can write D chart, or is also called as the NP chart. Case when the process standard is unknown, that is capital P is unknown. Then write the 3 sigma control limits are CL is equal to NP bar, UCL is equal to NP bar plus 3 times root NP bar Q bar, where Q bar is equal to 1 minus P bar, and LCL is equal to NP bar minus 3 times root NP bar Q bar. Where P bar is calculated using the formula summation D divided by NK. In this case, summation D is 25 divided by K is 10 and N is 50. So we get P bar equal to 0.05. I'll rewrite it here, that is P bar is equal to 0.05. Then find out Q bar, which is 1 minus P bar, 1 minus 0.05, which is equal to 0.95. So substituting, you get therefore CL is equal to 50 into 0.05, which is equal to 2.5. UCL is equal to 50 into 0.05 plus 3 into root 50 into 0.05 into 0.95, which simplifies to 7.1233, and LCL is equal to 50 into 0.05 minus 3 into root 50 into 0.05 into 0.95, which is equal to minus 2.1233, which is approximately equal to 0. 40th question. Solve the following LPP graphically. Maximize Z equal to 50x plus 60y subject to the constraints 5x plus 4y less than or equal to 40, 3x plus 4y greater than or equal to 24, and the non-negativity restriction, that is x and y both are greater than or equal to 0. So let's start with step 1. Convert inequalities to equalities. So 5x plus 4y is equal to 40 and 3x plus 4y is equal to 24. Next, step 2. To obtain the points of the two lines. So take the first line, consider 5x plus 4y is equal to 40. So put x equal to 0. So you'll get 4y is equal to 40, which implies y is equal to 40 divided by 4, which is equal to 10. And when you put y equal to 0, you get 5x is equal to 40, which implies x is equal to 40 divided by 5, which is equal to 8. So we write therefore 0, 10 and 8, 0 are the points of the line 5x plus 4y is equal to 40. Now take the second equation. Consider 3x plus 4y is equal to 24. Put x equal to 0. So you'll get 4y is equal to 24, or which implies y is equal to 24 divided by 4, which is equal to 6. Similarly, put y equal to 0. So you get 3x is equal to 24, or x is equal to 24 divided by 3, which is equal to 8. So therefore 0, 6 and 8, 0 are the points of the line 3x plus 4y is equal to 24. Step 3. To draw the graph. To draw the graph, on the x-axis, we'll take the scale as 1 centimeter is equal to 2 units. So first mark the origin, then 2, 4, 6 and 8. On the y-axis also, we take 1 centimeter equal to 2 units. So mark 2, 4, 6, 8 and 10. Now for the first equation, we had got the points as 0, 10 and 8, 0. So first mark 0, 10, that is this point is 0, 10 and 8, 0. Join these two points by a straight line, and on that line mark 5x plus 4y equal to 40. Now similarly, let us draw the next line. For the second line, we had got the 2 points as 0, 6 and 8, 0. So this is 0, 6 and this is 8, 0. Join these 2 points also by a straight line, and on this line write 3x plus 4y is equal to 24. So this is the way you have to draw the graph Then also write the scale. X-axis 1 centimeter is equal to 2 units. Y-axis 1 centimeter is equal to 2 units. Now let us move on to step 4. So what is step 4? Step 4, to obtain the feasible region. So to find out the feasible region, we need to consider the inequalities. So consider the first inequality, that is 5x plus 4y less than or equal to 40. Then put x equal to 0, y equal to 0. So when you do that, this left hand side will be 0, and then check whether 0 is less than 40. So 0 is less than 40, so within brackets I'll write true. Similarly, take the second inequality, that is 3x plus 4y greater than or equal to 24. Again put x equal to 0, y equal to 0 in this inequality. So on the left hand side you'll get 0. On the right hand side we have 24. Check whether 0 is greater than 24. So 0 is not greater than 24, and then you write false. So now going back to the graph, for the first inequality we got the condition as true. So this is the first equation and we have got the condition as true. So I'm using the red color shading lines. You have to shade towards the origin, that is below this line you have to share. For the second equation, that is for 3x plus 4y equal to 24, we got the condition as false, so you have to shade away from the origin. So I have used blue color lines. So when the condition is true, we have to shade towards the origin, that is the red colored lines. And for the condition which is false, you shade away from the origin, that means on top of the line. Now let us move on to step 5. So what is step 5? To find the corner points of the feasible region. So now what you have to do is you have to find that area where you have both the types of shading, that is the red color shading as well as the blue color shading. And because it's a maximization problem, you should always get a closed figure. So this is the closed figure, that is a triangle where we have both the types of shading, and this is the common feasible region. So now let us mark these corner points of the triangle as A, B and C. So the corner points of the feasible region are A 0, 6, then B is 0, 10 and C is 8, 0. The next step is step 6 is to evaluate the objective function at the corner points. So let's find out ZA. So ZA is 50 into 0 plus 60 into 6, which is equal to 360. Similarly, find out ZB. It is 50 into 0 plus 60 into 10, which is equal to 600. And ZC is 50 into 8 plus 60 into 0, which is equal to 400. Now, because it's a maximization problem, you have to find out which is the largest Z value. So it is 600. So next, write the conclusion. The given LPP has an optimal solution at B, that is 0, 10, and ZB is equal to 600. Section D, 8th main. Answer any two of the following questions. 2 into 10 is equal to 20. The 41st question, subdivision A, compute the net reproduction rate from the following data, which is for 5 marks. They've given us the age groups, female population, female births, and survival rate. So now first let us write the formula for the net reproduction rate. So let's start with consider NRR is equal to I into summation WSFR, that is women's specific fertility rate, into S, where I is the width of the age groups, which is equal to 5. So NRR is equal to 5 into summation WSFR into S, where women specific fertility rate is equal to FBX, that is female births at age X, divided by FPX, that is female population at age X, into 1000. So in the table, the female population, you can mark it as FPX. Female births, you can mark it as FBX. The survival rate, you can mark it as S. So now the next column in the table you can form is WSFR. And how do you calculate it? It is 90 divided by 6000 into 1000. So you get 15. The next one is 20. Then 60, 40, 25, 10, and 5. The last column is WSFR into S. So it is 15 into 0.90, that is 13.5. The next one is 18. Then you have 51, 34, 20.5, 8, and 4. Next, find out summation WSFR into S, which is equal to 149. So therefore, NRR is equal to 5 into 149, or NRR is equal to 745. 41st question, subdivision B, calculate the standardized death rate for the following data. The age groups, the corresponding population, deaths, and the standard population for each of the age groups is given. So the first step now is to mark the standard population as capital P. Then find out summation P, which sums up to 60,000. Next, let us write the formula for STDR, that is the standardized death rate. So consider STDR is equal to summation PA divided by summation P, where P is the standard population and A is the ASDR. So write the ASDR formula. It is number of deaths occurring in a specific age group divided by average population in the specific age group in 2000. So now in the table, form the next column as ASDR. So it is 266 divided by 14,000 into 1000. We'll get 19. Similarly, 9, 15 and 35. Okay. So ASDR is nothing but your A. Next column, find out PA. That is 15,000 into 19, which is 2,85,000. Then you have 2,70,000, 1,50,000 and 1,95,000. Then calculate summation PA, which adds up to 90. So we get STDR is equal to 90 lakhs divided by 6 lakhs. So on simplification, we get STDR is equal to 15. 42nd question, calculate the last payers, Pasch's and Fisher's price index numbers from the following data. Items are A, B, C, D. 2017 is the base year and 2022 is the current year. The price in the base year, it is marked as P0 and the quantity in the base year is marked as Q0. The price in the current year is marked as P1 and the quantity in the current year is marked as Q1. Next, we need to form 4 columns in any order. So it is P0, Q0, then P1, Q1, P0, Q1 and P1, Q0. So it is 20 into 14 is 280. Then we have 70, 170 and 300. So the total is 920. Similarly, find out P1, Q1. So 30 into 20, 600, 160, 300, 400 and the total is 1460. Similarly, find out P0, Q1, that is 20 into 20, so 400. Similarly, the other totals 112, 340, 250 and 1102. Next, find out P1, Q0, that is 30 into 14 is 420, 100, 150, 480 and 1130. So start with the first subdivision. Let us write last payer's price index number. P01 of L is equal to summation P1 Q0 divided by summation P0 Q0 into 100. So which is equal to 1130 divided by 920 into 100. So which simplifies to P01 of L is equal to 122.83. Next, you can find out purchase price index number. So consider P01 of P is equal to summation P1 Q1 divided by summation P0 Q1 into 100. So which is 1460 divided by 1102 into 100. So we get P01 of P is equal to 132.49. Next, let's find out P01 of F. So consider P01 of F, which is equal to root of P01 of L into P01 of P, which is equal to root 122.83 into 132.49. So on multiplying and taking the square root, the final answer is 127.57. 43rd question. Fit a quadratic trend equation of the form y equal to a plus bx plus cx squared to the following data by the method of least squares. Estimate the value for the year 2023. This is a 10-mark question. The two columns given are the x column and the y column. So the x values are the years 2018, 2019, 2020, 2021 and 2022, and the corresponding y values are 40, 20, 30, 15 and 25. So to start the problem, let us first write given the number of years. So n is equal to 5. Within brackets you can write odd. Then next write let y equal to a plus bx plus cx square be the quadratic equation. The next line, the three normal equations are, first one, NA plus B summation x plus C summation x square is equal to summation y. Second, A summation x plus B summation x square plus C summation x cubed is equal to summation xy. And the third normal equation is A summation x square plus B summation x cubed plus C summation x to the power 4 is equal to summation x square y. Next, you have to write where x is equal to, so whenever n is odd, x is deviation from the middle year divided by h. So here the middle year is 2020. So therefore x is equal to deviation from 2020 and h is the difference between the years, which is 1. So therefore you get x is equal to deviation from 2020. So now we need to form the columns x. This is not clear. It is x square. Then you have x cubed, x to the power 4, xy and x square y. So first let us find out summation y. So summation y is equal to 130. Next, we need to find out x. So x is deviation from 2020. So 2018 minus 2020 is minus 2. Then 2019 minus 2020 is minus 1. Similarly, you get 0, 1 and 2. So when we sum them up, we get summation x as 0. Similarly, x square minus 2 square is 4. Minus 1 square is 1, 0, 1 and 4. So you get summation x square is equal to 10. Similarly, x cube minus 2 cube will be minus 8. Then you have minus 1, 0, 1 and 8. So when you add up, you will get summation x cubed also as 0. Then find out x to the power 4. That is minus 2 to the power 4 is 16. Minus 1 to the power 4 is 1 and so on. So when you add up, you get summation x to the power 4 is equal to 34. Next is xy column. So it is 40 into minus 2 is minus 80. 20 into minus 1 is minus 20. 0, 15 and 50. So we get summation xy is equal to 35. Next is summation. We have to find out x square y. So x square y is 4 into 40 is 160. Then 1 into 20 is 20. Then you get 0, 15 and 100. So summation x square y is equal to 295. Let us now substitute all the totals in the three normal equations. So substituting in the first normal equation, we get 5a plus b into 0 plus c into 10 is equal to 130. So which implies 5a plus 10c is equal to 130. I'll call this as equation 1. Then in the second normal equation, you'll get a into 0 plus b into 10 plus c into 0 is equal to minus 35. So which implies 10b is equal to minus 35, or b is equal to minus 35 divided by 10, which is equal to minus 3.5. Substituting the third normal equation, we get a into 10 plus b into 0 plus c into 34 is equal to 295. So which implies 10a plus 34c is equal to 295. I'll call this as equation 2. Next, solving equations 1 and 2 simultaneously. So write the two equations one below the other. 5a plus 10c is equal to 130. And then you have 10a plus 34c is equal to 295. So we have to either eliminate a or c. So let us eliminate a. So the coefficients of a in both the equations should be the same. So what I'll do is I'll multiply the first equation by 2 so that here I get 10. And when we subtract this equation from the next equation, a will vanish. So which implies 10a plus 20c is equal to 260. Then the second normal equation, you will get 10a plus 34c is equal to 295. Now subtract both the equations. So you have to change this sign. So you will get minus 14c is equal to minus 35, or it implies that c is equal to minus 35 by minus 14. The minus signs will get cancelled and you're left with 2.5. Next, we have to find out the value of a. So you can take the first normal equation. So I'll take 5a plus 10c is equal to 130. So which implies 5a plus 10 into 2.5 is equal to 130, or which implies 5a is equal to 130 minus 25, which is equal to 105. So therefore a is equal to 105 divided by 5, which is equal to 21. So now we have to substitute the values of a, b and c in the quadratic equation. So we get therefore the fitted quadratic trend equation is yc equal to 21 minus 3.5x plus 2.5x square. The final step is to estimate the value for the year 2023. So from the table, for the year 2023, the value of x will be equal to 3. So therefore, y subscript 2023 will be equal to 21 minus, so in the fitted quadratic trend equation, it will substitute x as 3. So 3.5 into 3 plus 2.5 into 3 square. So which simplifies to 21 minus 10.5 plus 22.5. So which implies y 2023 is equal to 33. Please do practice this new model question paper which I have solved, and also refer to my various other question papers which I have solved previously. And I wish each one of you, my dear students, the very best for your board examinations in March 2024. Thank you all for watching and continue to support my channel.